All right, so I want to show you a video, and this video is a this video is very very important. Oh, they do not show, do they? Wait,
Can you click on it?
hold on, I got it.
I'm almost done popping on my nails.
Why are you
Anyways,
Excellent.
about me.
Sorry about it today.
Like calls me over to his desk and he's like, Julia, I'm sorry. He's like, this is a hard conversation. He's like,
Okay, so can you, yeah. Wait, am I showing or not showing?
"Who's going?"
No, I need to show. Oh, I need to. I'm a dum dum. Hold on 1 second. There's technical difficulty. Wait, let me stop sharing. Share Office. Okay, so it's showing the screen, right? No, it's not showing the screen. So, it's showing.
Building your business online?
Wait,
Go to Wix.com and get
Why
your
is-
site up and running with a tailored creation experience. Add what you need for your business and pick a design that matches your style. Customize it with complete
it's not
flexibility
showing on this
down to
video.
the very last detail. Turn it up with advanced animations and videos to grab people's attention.
Okay, so fine. I'll show you this way here. So if you go into I don't know if you guys seen this part of the movie, so which is Karate Kid. So wait, am I screen sharing?
Oh my god, is that the chess? Oh, did y'all see that?
The chess guy. Who's the chess
Okay, so there you go. Hikaru. So my favorite thing of this movie is the part walks on, walks off. Okay, there we go. In the fence. There we go. Okay, so this part of the movie, and the reason why we need to spend time on talking about this movie is kind of gonna give you a very visual image of what happened. If they're able to show it. Wait, why is not moving? Can you guys see it? So basically, he asked him to paint the fence, and he got really pissed. So he doesn't want it to do. He doesn't want to learn karate from him because he never teach karate. He just told him to sand the floor and walk. How many of you guys have not seen Karate Kid? Raise your hand. Okay, so basically, this part of the movie that he just told him. He just told him to that he's painting the fence. Well, he got bullied at school, and
Well,
and then Mr. Miyagi promised him to teach karate, but end up just asked him to do chores all over the house. So to be paint the fence or sand the floor and things like that. And he got mad. He's like, I don't want to do this anymore.
You know what, Matt? So
ow! Ow, what are you doing?
Oh, show me. Sat the floor.
How did you do it?
Shut up! Show me. Sat the floor. Sat the floor. Sat the floor. Sat the floor. And the floor.
So look at right here. Okay, so yeah, that part right there. And I'm gonna tell you something in a second. So this part is something that I want you to pay attention right here. Is this part here. This image, I want you to memorize this because this image is very, very important what we're gonna do today's lesson. So it's talking about concavity, okay? So if you down here, and there's another side is down there. So basically that is the thing that is very, very important for me. Is usually I want kids to memorize things, but not memorize by memorizing the fact, but memorizing the image. And the image is probably something that's very, very clear. So the image of that part, this part here, I'm gonna show you here. Very, very important. Okay, very, very important. Now, hopefully I can go back to the quick time. Problem is my iPad's not sharing, so I'm gonna have to start my iPad again. Unfortunately, today is not my day for technical difficulty. Hopefully, I can turn on my iPad. Okay, so we're gonna spend some time to talk about concavity and what is concavity, right? Now, if I would ask you guys, what do you think concavity is? Can you tell me without me telling you?
Like a bulb, right?
It's like what?
It's like a bulge. Like if you use like a glass mirror or glasses, it's like a bulge in glasses.
You're talking about convex and concave?
Yeah, like it's bulging outwards. So it's concave.
Okay, that's fair. Okay, what else? Anybody else have different thinking?
What concave or concavity?
Okay, good. My iPad's working. Great. All right, so what we're gonna do is we're gonna show you concavity, and the best thing to show you is do a Desmos website, and I'll show you here. I forgot what the equation is. I'm gonna just do x cubed minus 3x squared. Okay, something like this, right? I have this is a function, and I'm gonna say that's f of x. So a lot of time that you say, well, a lot of time that you say that this is a function. What is concavity? So I'm gonna show you concavity in a second. So I'm gonna do y minus y1, y minus y1. So it's f of a. And this is called equation tangent line. You should know this already. Is f prime of x. And you probably seen me done this a couple times already, which is this is just equation tangent line equation. And we're gonna do between -3 to 3. So -3 to 3. And we're gonna play. Do you see that equation tangent line there? Is going back and forth? Do you see that? Okay, so I'm gonna slow it down a little bit to like maybe half speed. So if you see what is concavity, the best way of explaining concavity is equation line is above the actual graph. If the equation tangent line is above the actual graph, that's called concave down. If the tangent line is below the graph, then it's concave up. So I'm gonna ask you, this moment is concave down or concave up?
Wait, I missed.
That's
I think
concave. It's concave down.
This concave down, good. Pay attention when they change, okay? Do you see that the equation tangent line changing from below to above at one point? So I'm gonna show you even slower. So just slow it down. So at here, I'm gonna maybe slow, maybe faster a little bit. So this is concave down. When you get to that point right there, do you see that? It changes from below to up. So that point is called inflection point. Inflection point happen around x equal to 1. You see that point? Here you cannot tell it's up or down anymore. But after that, it's going to be down because it's above. Does that make sense?
So when it's above, it's concave down, and when it's below, it's concave up.
Exactly. Okay, so that is the first understanding concavity. Are you okay? Shall I draw it to show you? Okay, I'll just draw it to show you. So if I have a function like this, right? Oops, my bad. The function is gonna be, man, everything's not working my way today. What the hell? Okay, so let's just say if I have any functions, I have something like this, right? So if I have this point here, it's concave down or concave up? Concave what? Concave up. So this point is concave up, right? And at this point is what?
Concave down.
So concave down because you see the tangent line. And that's the best way to look at it. Look at the tangent line. Now, there's somewhere in between those 2 points. It went from up to down. So like if you think about intermediate value theorem, it has to go to 0 if we go in from positive to negative. So this point here, we can call this point here, right here. If I draw a tangent line at this particular point here, I can't really tell you up or down. So this is called an inflection point. Okay, so that is the definition of things. That's the visualize of understanding. Is that okay? Sorry about taking this long. Sometimes they just changed a lot of things. Question about this part. Now, let's review a little bit. The first derivative test, that's first derivative. What does the first derivative tell you? If it's a positive, means what?
Increasing.
If it's a positive, means the function's increasing. The original functions, right? So f of x is increasing. If it's a negative, then f of x is decreasing. Okay, do you guys remember what's the first derivative test? What's the difference between first derivative and first derivative test? Yeah, first derivative test, you have to do number line test, but first derivative test tells you what? If you look at your notes, what's the first derivative test tells you? Right. It actually tells you if f prime of x change. You got to remember this phrase because when you're doing justification, you write this down from positive to negative at C. Therefore, C and f of C is a relative what? From positive to negative is it's maximum. So this is the one of justification you had to do. It's called first derivative test. You need to remember the word. It's gonna keep in a similar order. And if I do the same thing, if I paste it here, if it changes from negative to positive, it's gonna have what? Right. So negative to positive at C, therefore it's going to be relative min, right? So that's what's the first derivative test tells you. First derivative tells you if we change the sign from positive to negative, then that's relative max. If it's negative to positive, it's relative min. Is everything okay with that? This is what we learned last week. Let's just review. what the second derivative tells you? Well, second derivative tells you, if it's positive, then it's concave up. If it's negative, it's concave down. So does that make sense? If the second derivative is positive, it's concave up. If second derivative is negative, it's concave down. Again, this is the second derivative, so let me write down second derivative. If a second derivative x equal to 0, no, is a possible inflection point. Why is a possible inflection point? Because you still have to do number line tests. If you don't do number line tests, you don't know if they have a sign change. When the sign change, that's where the inflection point. But as you know before, when we do this first derivative number line, sometimes we get positive, positive, negative, negative, right? So there is only one sign changes, not multiple sign changes. Even though you have a 0, does not make sense that it always is going to be inflection point. No, it's a possible. So you have to do a number line test. Got it? Any questions so far? Okay. Now, there's also something called second derivative test. So second derivative test. So what does second derivative test tells you? Well, second derivative test tells you like this. So, I am gonna show you camera. So Nathan, you want to be my Danielson? Okay, come on. So you can stay right here, right? And I'm gonna stand right here. So what happened is I'm gonna tell you hang the fence, right? So do you remember how to hang the fence? Do you remember this thing when it's hang the fence? Can you guys see this or no? Yeah. Okay. So remember, if it's a concave down, this is what? If this is actual function, this is a horizontal tangent. Does that make sense? But if it's concave down in that particular critical point, this actually a maximum. So the concavity, instead of doing a number line test on the first derivative, you're gonna do you're gonna plug in the second derivative, see are they positive or negative. But plug in which point? Plug in the critical point. The critical point is the horizontal tangent. So at this point, it's gonna be up. Concave down, but is critical point, so therefore that is relative max. Does that make sense? Is that okay? So that's the second derivative test. Now let's go down. So here is, Deborah, pay attention.
I'm paying attention watching.
It's concave up here. If it's a concave up, then it's going to be a relative min at that critical number. Because here the derivative is equal to 0, but second derivative is positive. If second derivative is positive, this particular point is relative min. Does that make sense? So make sure inside your mind, I want you to memorize this image of here. If you memorize this image, it's gonna tell you that, you know, why that is. But the tangent line is also a good thing to tell. If the tangent line's on the top, it's gonna be a minimum. It's gonna be a maximum. If tangent line's on the bottom, it's gonna be a minimum. But also concave up. Does that make sense? Okay, thank you. So what kind of second derivative test? It tells you.
You're still up there.
Oh, I'm still up there. So second derivative test basically tell you is if you got a critical number, so let's just say f prime of c is equal to 0. Now if f double prime of c is equal to, if it's greater than 0, if it's greater than 0, then f of a c is what? It's a relative what? Can you guys tell me? Relative Minimum, good. It's a relative minimum. Why? Because it's concave up. If it's concave up, then you're gonna have that. Does that make sense? So if f prime of c is equal to 0, and if f double prime of c is less than 0, then c f of c is what? It's relative max. And remember, first derivative test or second derivative test always tell you the same thing. Tells you where is relative max and min. It only tells you that. So even the first derivative test tells you increasing, decrease. First derivative tells you increasing, decreasing, but first derivative test is see the sign changes. Then that's going to tell you relative max and min. The second derivative tells you concave up or concave down. If it's positive, it's concave up. If it's negative, it's concave down. But if you're talking about second derivative tests, then if the f prime c is equal to 0 and f double prime of c is greater than 0, which is concave up. If it's concave up, that has to be a relative min. And if the other way, if f prime of c is equal to 0, and if f double prime of c is less than 0, then it's going to be less than 0. It's going to be like this. Then it's relative max. Does that make sense? No? Natalie?
Yeah, like minimum and maximum.
Yeah.
According to your relative max, the concave needs to be down.
Yeah, but so look at the image. Look at the thing. So what I want to do is instead of ask you to memorize this, I want you to memorize the image. And make sure you remember the Karate Kid because we're going to keep on talking about it. That way it's going to help you memorize instead of memorize a mathematical statement. Does that make sense? Okay. So that's a way. So I'm going to just show you this equation. So I think we start with this equation says f of x equal to x cubed minus 3x squared. Now I want to show you everything. I want to show you how I did the first derivative, and I will show you how the number line test. I will show you second derivative and number line test, and to tell me all the information instead of just like one thing. I'm also going to show you how do I do the grids.
Can you enlarge your screen?
Yeah. So now what happened is I'm gonna have first derivative. What is the first derivative? 3x squared minus 6x, right? Can I do a number line test? Well, I can take out x, right? So I can do a number line test. Now make sure the number line test, I'm going to align it along with the second thing. So 0 and let's just say here is 2. Is that okay? And so negative infinity to infinity. And why do I align it that way? Because I'm going to show you in a second. If I have this, it's going to be negative, positive, positive. Does that make sense for number line test? And this is negative, negative, positive. So it's going to end up positive, negative, positive. So this is increasing, decreasing, and increasing because this is the f prime of x. Does that make sense? Now, what does this make? Is a relative max or relative min? So this is relative max and relative min. Does that make sense? This is what we learned last week, right? Now, let's go into the second derivative. If I do the second derivative here, that's equal to 0. So that's 6x minus 6. And then second derivative equal to 0 is x is equal to 1. So what I'm going to do is I'm going to do a same number line test, but make sure I have the same increment on the bottom, but it's aligned. So this is still 0, this is still 2, but even though I don't need to test it, so 1 is going to be in between. Does that make sense? 1 is between. See, I aligned it to the top. Because you set 6x minus 6 is equal to 0, x is equal to 1. Right? 6x minus 6 equal to 0, 6x minus 1 equal to 0, x equal to 1. Does that make sense?
Yeah.
Now, if you see this one, I place right here, right in between there, because that can tells me a lot of information rather than anything. So this one's gonna be a negative, and this one's positive. So it's gonna tell me concave down, and this concave up because this is second derivative. Does that make sense? This one doesn't tell me increasing or decreasing anymore. Are we okay here? Now, the question can ask you says, what's the inflection point? Can you tell me what the inflection point is? Yep, x equal to 1 is going to be inflection point. Even though I need to get y coordinate, but I will have to plug in to get the y coordinates. Are we okay here? Now, the question can tell you which part is concave up. Which part is concave up? Concave up is from 1 to infinity. Does that make sense?
Yeah.
Now, what can other question can ask you? The other type of question they can ask you says, hey, can you tell me which region this function is concave down and decreasing at the same time? That's why you align them correctly. Can you do concave down and decreasing? Which region is concave down and decreasing? Why?
Because you have to line both of the number lines. It's only decreasing from 0, but then it only stays down to 1.
Does that make sense?
Yeah.
So I can ask you all different kind of question. I can ask you when it's increasing concave up, then you're gonna say from 2 to infinity. I can ask you when it's increasing, when it's decreasing concave up, it's gonna be 1 to 2. So they can ask you a lot of information on the AP exam. So you have to make sure you do when you do a number line, you align them correctly. You align them correctly, it will make your job easier when you're doing stuff. Does that make sense? Okay. So that's second derivative. So the only thing is you do the same thing before. But let's look at this critical number. If I were to plug in 0 and if I go to here, it's concave down, right? Which just makes sense. Look, it's concave down. It's a maximum. If I look at here, it's a positive. It's concave up. It's minimum. You can look at the second derivative to decide that too. So you can tell the maximum and minimum using second derivative tests. Are we okay here? Okay. So we're gonna give you the homework early. So I'm gonna airdrop to you, and the homework looks like this. But except the homework is gonna be a little bit you have to think about critically. Now, like I said, you should do your homework like intentional practice. And then like what Mr. Miyagi told you says you should focus while you're doing the homework. There's a significant difference. You're not gonna gain skill if you're not focused while you're doing homework. Like say you check out TikTok while you're doing homework, you are not focusing. You're not focusing, you're not gaining skills. If you're focusing, you'll gain skill because you will think about how to do things. So I'm gonna airdrop to you. Oh, it's everybody here. I don't know who this guy is, but it's okay. I'm gonna drop to random people. Nokia phone.
Is there a turn it on?
Yeah, you have to go to settings and then hit airdrop. Sometimes.
Now, I'm not going to teach you how to do chain rule and quotient rule, and you do need to understand when you need to do chain rule. One thing about your homework, you have to do number line test to verify maximum, minimum, and inflection point. You cannot just say, oh yeah, f double prime x equal to 0, that's inflection point. That's not true. You have to do a number line test, and you have to do it correctly, okay? There is go, Julia's iPad. Why are you iPad?
My phone's connected to.
Your phone is connected to your iPad? Anybody didn't get it? So you should start your homework here.
I didn't get it.
You have 4 minutes to finish your first question. First question is actually quite difficult. You have to pay attention. What kind of derivative you have to do. And what kind of trig function you need to know. Also, I'm going to give you a hint. It has something to do with double angle identity. So Yes, you cannot just shake your head, but it's one of the things that you have to know. That's why I give you a test about trick identities. Yeah.
Yeah.
That could be a problem.
Is that sin squared?
Yep. Careful how you take a derivative on the first one. And even before you go into the second derivative, I recommend double angle because you should see a double angle. It'll be easier to do double angle and take a derivative rather than derivative a product rule. If you did it right, the answer is pi over 4 and 3 pi over 4. I'll see you guys later.